Science in Information Technology. Then he received his Master of Science in Data Communication Systems from Brunel University, United Kingdom. He is a senior lecturer in UiTM and has been in this field for 14 years. Nurtures the interest in IoT and electronics since the last couple of years, because he feels that technology is heading into that direction. Okay, how are you doing, Mr. Suhardi?
I'm good. Thank you very much.
Okay, without further ado, I would like to welcome our honorable speaker, Mr. Suhardi Hamid.
Thank you, Dr. Afida, and Assalamualaikum, and good morning to everyone who happens to be quite surprisingly quite a number of you have turned up, considering that basically we have a very short view and for the promotion. But eventually, yes, what we're trying to cover today is to simplify IoT with block CLI. Yeah, as the name suggests, it's not meant to entirely make you feasibly comfortable with IoT, but basically what we're trying to accomplish here is to garner the interest and spark the interest so that you can pursue more into the topics. Right. Before we begin, it's probably best to understand what we'll try to cover for this particular session. All right, these are the things that we will cover today, and hopefully we'll be able to cover the whole thing as what I've planned. Basically, we'll get on with some introduction on the Internet of Things, the block CLI, MicroPython, and sort of stuff like this. And as what I've planned, basically we'll get on with some introduction on the Internet of Things, the block CLI, MicroPython, and sort of stuff like this. And once we're done with the introduction, we'll try to get accustomed or get to know the devices that we have, right? In order for us to start doing the project, we really have to understand and get to know the devices that we have. Then only we can proceed with the coding. And we'll try to have a look at how to go about coding using the block CLI application or environment. And finally, we can test the codes. And we'll cover some of the basic things, not entirely the whole 9 yards, but if you do not have the device, we can still simulate the code. Yeah, simulate the code, because from what I gather, at least in my experience, yeah, we get to know so many different programming languages, and sometimes it can be quite taxing to learn a new language. So having had the capacity to understand the coding, perhaps we can try to simplify that by having some interface, as in having the visual programming language that can help us translate the codes into the real programming language. Yeah, essentially that is the case, and we'll have a look into that. It's not that too technical, but it's just that you have to understand and to be able to switch your perspective towards the IoT. Coming from the information technology background, I am accustomed to only the software part and not having to deal with the hardware part. So these are something that I have experienced and experiment myself. So to say the least, it's not rocket science, and it can still be achievable, considering starting from this semester, most of the subjects, at least CSE subjects, have started to integrate the IoT into the subject to a certain extent. So it's probably best to at least try to understand the capability and what we can do with this and how to get accustomed to this. So the Internet of Things normally refer to small devices, integrated with sensors that are connected to the internet. And what are these devices? These devices normally run on microcontroller, which is basically a subset of microcomputer. We have got like many different small products. I'll show you some of it. Now, here, what you can see is an example of ESP32. We have, hold on. Oh, hold on. It's not working now. Why is it not working? Okay, never mind. We'll get into that in a bit. But for now, I was going to show you some of the devices that I have that maybe you can probably try to relate. The difference basically between microcomputer and microcontroller is that microcontroller performs specific set of tasks in continuous loop. Unlike microcomputer, it can be a computer, to say the least. So having a computer, you can do many things, but it requires a different set of programming, whereas for a microcontroller, it can only perform a very specific set of tasks that will run continuously. Basically, take for example, we want to capture some sensors and store the information into the internet. It is possible. Yeah. The number of tasks is highly limited to the number of pins that we have on the microcontroller. Communication signals are sent via pins, occasionally resembling the networking communication via ports. It's like when you try to communicate with microcontroller, these pins, yeah, I have to get this sorted basically, otherwise it's really difficult to show you. I want it work now. All right, now it's working. So, as I was saying, we have pins and we communicate via pins. And these are the pins that I was talking about. Yeah, these are the pins that I was talking about. And again, there are pins as well. So, basically, that's how we communicate with the device. However, it is best to note that to date, MicroPython does not have the ability to connect to WPA2 Enterprise or EduRoam for that matter. If you were to communicate or if you were to connect to the internet from within the campus, we'll have to either use our own Wi-Fi or, well, that's just the only way. We have to use our own Wi-Fi because UiTM network are basically connected via EduRoam, right? Or perhaps if you do not want to use that, you can use a different ecosystem such as Arduino. Arduino does allow for connecting to WPA2 Enterprise. So Next part on the introduction is on Blockly. It is a visual programming environment developed by Google to encourage people to get into programming. So programming, especially for beginners, can be messy. Yeah, it's not straightforward. You have to tune your mind into problem-solving mode so that you will be able to do the coding. And besides that, it's basically a new language, yeah, that you have to learn and get comfortable. So it can be difficult. Generally runs on a client-side computer, this Blockly environment, and has the ability to convert into different programming codes, such as JavaScript, Python, etc., depending on how you set it up. And Blockly is pleasantly appealing with different color blocks that snap to each other. We'll get into Blockly in a bit. MicroPython, yeah, most of the, at least in UiTM, are quite familiar with Python because it's part of the syllabus. But then again, in the case of myself, I've never actually learned that Python programming language and never actually taught the subject. So Python can be quite, I would say, new that I have to learn. So a MicroPython is exactly like Python, only that it is a very small scale programming language. Yeah, out of Python, they create a subset of that Python so that it can be pushed into small devices like what we have here. It is an interpreter-based language. No compilation is required. Basically, you have to put Python into your devices so that you can start to code, and implements REPL, read, evaluate, print, and loop, like the parent programming language. The Python programming language also implements REPL, and therefore allowing code's interpretation on prompt. It's like you are doing the coding directly onto the device. It's quick and easy to test and fix your mistakes or your codes. Now, we can move on to know your devices. Yeah, IoT devices come in many versions, and each version may be different in its capability. As I was saying earlier, yeah, we have, this is ESP. Sorry, this is right. That's right. How do you move this? It's always tricky. All right. This is basically ESP32. Yeah. And we also have ESP8266. Now, this is somewhat newer. This is called Raspberry Pi Pico without the wireless. So if you notice, the pins underneath are not the same. Some are shorter, yeah. Some have more, and even here, yep. So besides the processor speed, flash memory size may impact your approach to the device. Yeah, an old version may not have enough or sufficient memory to cater for longer codes. All right, so these are the things that you have to take into consideration before proceeding with these devices. But then again, in order for you to test it, it's fine to acquire any one of them. And these are not that very expensive. While codes may be reused, ensure that correct pins are connected to the sensors. Yeah, if you were to connect to services online, we communicate via ports, and these ports must be correct. Similarly, when we communicate on these devices, we have to identify the pins that we use because the signals will be sent into that particular port or pin, sorry. Kindly have device pin out diagram handy to understand the pin functionality. In here, we have underneath here is an example of ESP32 room development kit full pin out. So basically similar to the device that I have here. And you can look for this information online. There are plenty of diagrams available, provided that you compare that to be similar to what you have. So in here, you can understand that there are GPIO pins. These are the general purpose input-output pins that you communicate with. Yeah, and we have got different colors. If you want to have touch sensors, and these are the pins that you can connect. Instead of all the pins, you only have the ability to connect to the touch sensor. Yeah, if you want to use I2C, for example, these are the only pins that you can use to communicate. So these color codes and pins sometimes are assigned directly. But then again, it's not that difficult to really master this, only that you need to experiment more. So while IoT devices may come built in with multiple sensors, most only come with bare minimum. Not much sensor integrated inside that. But the one that I have here has got plenty of sensors inside, but it's expensive. It's commonly, where is it? Let me see. It's probably here. Okay. Yeah, basically this is one. I peel this off. This is one. It's more expensive, but it's got quite a number of sensors integrated in the board. We have Bluetooth, we have pins, we have LEDs. Yeah, we have LEDs on board, 25 altogether. We have the speaker, we have microphone, and we have, what else? The accelerometer and gyroscope, if I'm not mistaken. And these are all integrated inside the simple board or small board like this. It's called the microbit. Yeah, it's called the microbit. So these sensors, basically, these sensors can perform specific tasks as well. Yeah, these sensors can perform specific tasks. The functionality of the IoT devices can be extended with appropriate sensors for the purpose. Yeah, if you want to sense perhaps the temperature, you will need to use the temperature sensor. Each sensor has different requirements and can be obtained from data sheet. And this is also mandatory, I would say, that you check the requirements for your sensors. Some are working on 5 volt, some are working on 3 volt, yeah, depending on the sensor that you are using. If you are giving 3 volt to 5 volt sensor, it won't work. And similarly, if you give 5 volt to a 3 volt sensor, it may burn your sensor. So those are the kind of things that need to consider.
Hi, Mr. Sawadi. Sorry to interrupt. I'm just can I ask question?
Yes,
If any of you guys want to ask question, but I'm very interested in all those what you call it? Is it the all those microprocessor, right?
Yes, correct.
What about the pricing? Is it expensive? I'm just wondering because there's a few, kan?
Okay. The pricing Basically, okay, let me try to, they are available online, especially on Shopee. But this is ESP32. The pricing is approximately, I would say 20 ringgit for the generic one like this. Again, this is somewhat old as well. There are new ones, can be slightly more expensive. This is ESP32, this is ESP8266. The price about 10 ringgit. Yeah, this is price about 10 ringgit. This is Pico first version without the wireless. I think this is priced about 17 ringgit. This is Microbit version 2. It's priced, I think, about 76 ringgit. What else? Sensors can be cheaper, about 5 ringgit. For example, this is the sensor, 5 ringgit. Yeah. So it's not to say that they are very expensive. It's just that, yes, it's quite interesting, I would say. Not expensive. Still, I would say within budget.
Depending on what we want to do with the controller, is it?
Correct.
But Microbit is a bit expensive.
Microbit is a bit expensive, but it's easier to learn on Microbit.
Oh, I see.
So, again, still on, as much as we get into coding, but still I would say on the introduction part. Yeah, setting up IoT connection requires the driver to on Windows. Yeah, these devices, if you want to make them communicate with Windows, you must have a driver similar to any peripherals that you purchase. Yeah. So for ESP32, the one that most of the UiTM are using nowadays, commonly use CP210X USB to UART bridge VCP drivers. You can download online, no problem. So having said that, if you notice here, this is basically, as much as you connect using USB, it's still using UART, which is serial. Yeah. So if you are communicating with serial bus, there's nothing much that you can do because it's basically slow. Yeah. But nowadays, most of the new devices, for example, this one, the Raspberry Pi Pico, it's using USB instead of UART. So not only that it's faster, but it's easier to handle as well. Right? Next is to flash the device with MicroPython using the link here. So as I was saying earlier, you want to get used to MicroPython or you want to code into the device, you have to put the MicroPython tool inside here first. So we can do that in a bit. You click connect. Yeah, underneath here you have connect, and you have to choose the driver that you are using. Yeah, the port that you're using, either COM1 is not possible. So in this case, CP2102 USB to UART is communicating on port 3 and connect. So basically you follow the instruction and it will get installed within 2 minutes. This is the environment for the coding. Yeah, this is the environment for coding. You can use the Arduino ecosystem, but that requires you to install and requires quite a bit of space. It can be big. Yeah, the files can be big. In this case, we'll try to have a look at something simple and lightweight. So we'll use the browser. There's no need to install anything unless you want to download it for your offline project. You can still do that. They offer the offline files for you to install on your computer. And basically, the IDE here is compatible with numerous IoT devices. So that's a good thing. And how do you code? You simply choose the functions drag the object, and get them to snap to each other. Right? And once you have done that, you need to connect to your device. Notice here, ESP32 is selected. This is connecting using Wi-Fi. You have to change that. And once you're done, you can click on the plug button here. Testing your code. Basically, once you have done the code, something like this, click on Files. Yeah, click on Files, and my project.vibes.py will generate the code for you. This is the code, the corresponding code based on the Blockly objects here. So that is done. If you want to send it straight to the device, there is a play button on top of here next to ESP32 or your device. So simply click play and the codes will be sent into your device. So any serial output can be viewed on screen. Yeah, the console tab, and you get to see the output. Right. But if you do not have the device, you can copy the code and paste it here. Yeah, go to walkwe.com, this link, paste your code, and click on the play button. Yeah. So it's not entirely, I should say, it can be complicated, but then again, what I am showing you is something that get you going. You can work on this on simple stuff. Yeah, on simple stuff, not on the difficult and complicated stuff. To get you started. After you're done with this, then you can pursue further into the topic. So that's that. Next is to get going with the code. Simplifying IoT with Blockly PDF. Okay, this is the one that I've done. Yeah, this is the one that I've done, a step-by-step instruction. Basically, you can download and install your driver into the computer. I believe that some of you may not have the device, so it's fine if you do not have that. We can proceed with identifying the COM port to understand or to find out which port that it is communicating. Again, if you do not have the device, you do not have to do this just yet, but we can get comfortable with the IDE. Yeah, if you want, you can try to work on this. Go to vibes.net.br/IDE, Control C. I'll paste that onto here, onto the chat. If you want to access that, I'll just send another link first. Now, these are the two links that you need to use, basically. Where is it? So I have mine open as well. If you want, you can try this and get comfortable, and you can see that it's not that difficult. Yeah, we loop, repeat 10 times. The output pin, if you notice, I set that to use GPIO2. Now, GPIO2 is basically the standard LED pin on board. If you have the ESP32, GPIO2 connects directly to the onboard LED. And this is what we try to use, or what I've done. Yeah. Set output pin, go to machine. In out pins, set output pin, GPIO2 to true. And then we delay so that it takes some time. Delay 1 second. Copy again, duplicate, set to false. Copy the delay, and snap. All right. Once we're done with this, we can check the files. All right. Codes. Basically, you simply have to copy and paste it here. This is ESP32. And start to run it. Notice that lights up 10 times. So even if you do not have the device, you can still try the IoT. Once it's done, it will prompt you to the, it will get you or drop you at the prompt where you can type something. Help, for example, help modules. It will give you that. Right? So, yes. These are the things that you will do on the device. All right. Now, after testing that onto here, and it's working, we can stop here. We can stop. And if you want to test that directly onto your device, we can still do that as well. It's fairly easy. Simply connect your device. GPIO2. We are connecting to GPIO2. I have that ready. Hold on. So basically, I don't need that. Or perhaps I just, hold on, let's see. Connect to here. Okay, that is my ESP32. This is my, all right, there you go. If you can see, this is pin number 2. Yeah, D2. Simply connect. All right. If you want to install, you can simply connect to the device, communicating on COM port 3, connect, and you can install MicroPython 117. Connect, install, and we'll wait. So basically, again, only about 2 minutes. It's not too long to install. In fact, the file size is approximately between 1 and 2 megabytes. So under normal circumstances nowadays, they're not that big, yeah. And it's fairly quick for 2 minutes. Sometimes it takes even longer for some other things, but here it only takes 2 minutes.
So basically, where do we use this MicroPython for? What do we use it for? Like to code, maybe some real life example.
Yes, we'll get into that. For now,
okay.
we'll get into that. For now, if you are familiar with programming, the first thing that we do is to create hello world. And by lighting up the LED, this is the hello world in electronics. So that's the first thing that everyone should do. And after that, only we can connect to some sensors and make sense to the IoT that we are creating. Okay. Once we're done, can refresh, because if we don't refresh, sometimes the connection is still there and we won't be able to use the device. And Bytes project, let me see. All right. So now that we've done that, simply send the code or make the connection to the device. Choose the ESP32. Make sure that you're connecting to serial because we're communicating on COM port unless you set up the network. Connect and click connect. Now it is connected, and send it across. Check the console, send it across. It is being sent. Unfortunately, the device that I have here does not have the onboard LED. Yeah, does not have the onboard LED, and therefore, if you want to see, notice here it drops to the prompt again. Basically, it runs the code, but it won't show you because it doesn't have any onboard LED. But we know that we are connecting to port number 3. Sorry, port number 2, and therefore we have to connect the LED to port number 2. Use that LED. Always remember the shorter one is for cathode, which is for the negative. Yeah, for the negative. Let's connect it here. And since LED can only accept small current, we have to interface that with resistor. And this resistor is 220 ohm. Resistor 220 ohm. It doesn't matter which way for the resistor, but it is very important to get the correct polarity for the LED. LED2 into the resistor. Then the resistor will pass the current to the LED. Now the negative port here, yeah, the negative leg must complete the loop. Complete the loop onto the ground. Where's the ground? Okay. All right, I can see the ground. This is the ground. And connect that to the ground. Send that again. Now it blinks 10 times. Okay, and once it's done, it drops into the prompt. Okay. So basically, these are the kind of things that you can do using the ESP. So in order for us to get on with real life example, perhaps we can try to make sure that the Hello World program work first. If you want to do this using what we here, you can simulate exactly what you have seen earlier onto the device. Yeah, you can simulate exactly what you've seen here on the device. Basically, you would import the breadboard, the resistor, the LED, and connect them accordingly. Is there anyone interested to try this? Boleh kan nak try?
Boleh using what we
Yes, correct.
So first we code in bytes, tu tak? So
Correct.
first we code in bytes.
Yep. Code in byte.
You drag everything in blocks, kan?
Go to
Where
file.
do you get the delay?
Delay
Find the delay.
should be in timing.
Timing.
Delay should be in timing.
Okay. Alright. So what about the pin? Since I don't have the device.
It's okay. Use the standard GPIO2 because GPIO2 is the standard output pin. For LED.
GPIO2.
Yep.
Oh, okay. GPIO2. And then you have delay.
Alright.
Okay.
Alright. First you set to true, which is to light it. Then false to turn it off. Second, repeat 10 times.
Okay. So you can just copy paste using the short key, the same
Correct.
short key.
Correct.
Oh, okay.
Go to files, Control A, Control C. Go to here, paste it on MicroPython. Main.py.
Control A, Control C, and then you go to what we, right?
Correct.
Okay. So I have my what we on. Okay, what we paste it.
And we run the simulation. From here we can see the LED blinks.
Okay.
Now simulate to simulate that with the breadboard. Simply add the breadboard.
Okay. So anyone else joining us doing the hands-on? So add the breadboard. Where do I add the breadboard?
Click on the add new part, the plus sign.
Oh, plus sign.
Right.
Okay.
Scroll down.
Oh, I see.
until you get to half breadboard. So move it a bit so that you can see, right?
Okay.
Add the LED, right? So here, A anode, C for cathode. Cathode will connect to the negative, anode will connect to the resistor, basically. You can connect either way, basically. It doesn't really matter, only that you have to understand that the cathode will always go to the negative pin. Yeah, will always go to the negative pin. So add the resistor. You can type resistor. All right. In this case, I think what we can do is to clip the device that is for anode. Bring it here. All right. And one more thing. Okay, hold on. Before we get to that, it doesn't matter. Now we simply make the connection. D2, ESP D2, click and connect to R1. R2, connect to the anode. LED 1 cathode, connect to the negative pin on the breadboard. And the ground, connect to the ground.
So how do you choose DD to? D?
Notice here, it's D2.
So because just now we have chosen number 2, is it?
Yes, correct. GPIO, we said GPIO 2, so it's D2.
Okay. So that goes to... Okay. So this one goes to the anode and then the goes to negative.
Correct.
Okay.
And start the simulation. Notice it blinks. Only that it's not as bright. That's because this is 1000 ohm. Yeah, 1 kilo ohm resistor. What I have on my device here is 220 ohm. So hold on, where is it? Yeah, this is 220 ohm. If you want to change that, click on, stop first. Click on your resistor, click on diagram, scroll down until you see resistor 1. Hold on. There you go. Resistor 1 changed from 1000 ohm to 220 ohm. Yeah? 220 ohm. If we run again, you notice it's even brighter. Because we now have lesser resistance. And apparently they are blinking at the same rate.
Okay.
So that's for the hello world. So Vida, shall we stop for a bit?
Yes, sure. We can have a 10 minutes break. Is it okay?
I'm okay with that.
Is everyone okay? 10 minutes break? All right, so I guess, okay, thank you. So I'll see you again at 12:10.
All right, when we come back, we'll try the real thing. Inshallah. Thank you.
Okay. All right, everyone. So I hope you guys had a good break. Okay, so can we proceed, Mr. Sadi?
Oh, yes, yes. So what we'll try now is to simulate the temperature sensor. Yeah, we'll try to simulate the temperature sensor. Looking at the diagram, basically you can connect to any of the sensors, any of the pins, doesn't matter. But it's probably best that if you want to get a hands on to this, we can probably try to basically set up the environment like this. Once we know that it's working, then only we can try to save the data onto Google Google Sheets. Yeah, from here you can do your.
Sorry to disturb you. Are you like
Oh,
sharing
hold
your
on.
screen or something?
Oh yes, I should have. Sorry. Entire screen. So as I was saying, what we'll do now from this point forward, basically we'll try to test the sensor, temperature and humidity sensor, connect to the device, and then we can simulate that until we get the temperature, and afterwards we can export that information into Google Sheets. So this is something that probably you cannot do because if you do not have the device, then you cannot do, because this will require internet connection, the device, as well as basically everything. You need to have all of this to try, but you can try to get the values from the sensor. So how about we can try this together? Then I will show you how to proceed from that point forward. All right. So
Okay.
here we go to what we. Now, instead of having these components, we can try to remove them. No longer need them. All right. We can import the sensor, DHT22 sensor. And if you notice, it has 4 pins. DHT1, pin number 1 here, it says here VCC, which is voltage. Now the sensor operates at 5 volt. Hold on. Where is it? Here. DHT22. It says here it operates 3 to 5 volt. Here 3 to 5 volt, DHT22, right? But it's best to give it 5 volt. Will be easier. Yeah. And the device that we're using does have pins with 5 volt. Oh, it gets stuck again. Okay. Yep, it does have pin with 5 volt. How do you identify? Best if you have multimeter handy, but otherwise it's always the case. Yeah, it's always the case. Here in this case, we do have 5 volt. Hold on. We do have 5 volt. Yeah. Look for the information. ESP32 pin out. This is the one similar to what I have. Open Okay, this is similar to what I have. We have 5 volt, but if you are using a different version, then look for the pin out for your particular device. All right. In this case, it's clearly labeled as 5 volt. And sometimes if you go for ESP 8266, if you do have that pin out, notice we have 3.3, 3.3, 3.3, and no 5 volt. So V in normally produces 5 volt. And sometimes they'll give it something like VUSB, virtual USB, which is also 5 volt. Apparently USB is giving out 5 volt. So that's the thing that you have to keep in mind. Now, for this particular task, we are going to simulate that using this pin. And this is pin number, hold on, can't see. This is pin number 5. Yeah, this is pin number 5. This is 2, 4, and this is 5. So I'm just going to use what I have here. Will be easier. Yeah, I'm just going to use what I have here. Will be easier. First, I'm going to set up here VCC to connect to 5 volt. We'll carry the V in here that produces 5 volt into the port here. V in to here. All right. Ground to ground. VCC to here. Second port is SDA. This is the one that we want to connect to D5, or you can use any of the pins, provided that you know, and take note on the number because that will be represented. Yeah, that D is discarded and we get the numbers only. So I'm going to use D5 to connect to DHT1. That is NC, not usable. Ground to ground. So we have the network set up. We have the network set up and we can go to bytes. And we'll start with the loop. We want to repeat 10 times. If you want to repeat all the while, you can use repeat while true. But here in this case, for the example, we'll just try to do it 10 times. Repeat 10 times. Now we are going to use the sensor. Yeah. And in sensors, we have temperature and humidity. We are going to use that. Start the service first. DHT 22. Communicating at pin number, was it 4 or 5? Again, I forgot. This is D5. D5, look for GPIO 5. Nope. GPIO 5. Let's see whether that works or not. So that is done, we start the sensor. We want to repeat 10 times to read. Basically, we want to print that onto the prompt. If you want to print, go to text.
Sorry, Suhardi, I just want to ask. So, like my pin, there's only D1 GPIO5.
Come again?
I don't have the C5 CS GPIO2. I don't have that.
Are you using ESP32?
ESP32. Oh, I have to change that.
Correct.
Oh, okay. So I have to change to ESP32. Then only I change the GPI. Okay. Right.
So here we want to print. Yeah, we go to text, choose print. Underneath here, print. What do we want to print? We want to print the temperature and humidity. So two things. So when we have quite a number of things, perhaps it's best to create text with. Create text with. Now we have two snapper. Oh, is that what you call? Right? And we add more items inside so that we can add the text. Temperature. All right. Duplicate. Put the next one, humidity. Okay. And we'll try to concatenate that with the sensor get the temperature. For the temperature, get the sensor humidity, get DHT 1122 humidity, put it here. Now we want to delay a bit. We want to delay a bit because otherwise it can be extremely fast. So go to timing and delay for maybe 1 second. Delay for 1 second. For real life, then perhaps we can delay for even longer. But here we want to show something quickly, so we delay by 1 second, and that should be sufficient. Okay. So by this, we'll start the sensor, then we'll simply display the values onto the screen. Go to files again, copy and paste it here in main.py. And we can start the simulation. If you notice here, we get the temperature and humidity printed.
Sorry, they're just asking if you want to change in the files part. Let's say time slip 2, I want to change it to 5. It does not translate in the blocks, kan? Is it?
No. Because here is a different project. This is a different project. So if you want to change here, it's still possible. or in the block, you can change that to 5. Then you get 5. You get 5.
So you have to change in the block, not the files lah. Is it?
It doesn't matter.
No, it doesn't matter.
It doesn't matter.
Because what you're going to take is the files part. Is it?
Correct. Even when you have the block, what is being sent to the ESP is basically this code. Yeah, these codes will be sent to the device instead of the block. The block just simply make it easier for us to code. Yeah. And if you notice here, sometimes we do not know which library to import. That helps. And we do not know how to perform the for loop. That helps. How to join string. That helps. It's easier to code in blocks and get it translated into codes.
For temperature though, I got something like length because I think I use a different block. So is there any difference with length of temperature and just temperature?
Length of temperature?
The block. So the temperature you got it just the temperature kan? Because mine is length of temperature. I think I use a different block. Not that one. The green one. The green, I think it's in the text.
It's in the text.
Text.
You get length. If you
So-
get the length, then it will calculate how long is the text. If you get one with print.
Green. Okay.
We print.
But if I take the print one, I cannot put it inside the puzzle.
Right. If we go with print, text, we print, we create text with, so that
Okay.
allows for concatenation.
Okay.
Text, create text with, and we get that. So here
Okay.
we have 2 slots. Yeah, we
For
have
the
2
smarts
slots.
too.
We want
Okay.
to add more. We want to add more because here we want to write temperature, concatenate with the temperature. Then we write humidity. We concatenate that with humidity.
Okay.
So simply click on the gear button, drag the item so that you can have more.
Okay. Next step.
Once we're done with that,
Okay.
at 4. Now we want to put temperature. Text here.
Oh, that one. Okay. Alright.
All right, temperature. Copy, duplicate, paste it here. Humidity. Space between. And then only we slot in the temperature and humidity. Using it, delete.
Alright.
Alright, and go to files. So you can copy the code, paste it here, run the simulation.
Okay.
Does it work?
Since I don't have any temperature, is it? Also, you can.
You don't get any temperature. You get DHT.
Yes.
Did you start the sensor? And choose DHT. Yeah.
Okay.
Right. Now get the temperature. Here, temperature and humidity. Get DHT 11 or 32 temperature. Paste it
Okay.
here.
Okay.
Right.
Right.
Okay. From here, we can see that it produces the temperature and the humidity. As much as no devices or components have been connected, it's still possible to generate that. So basically, we understand that the code is working. Now we want to send this information to Google Sheets. I'm going to go to my Google Sheets, drive.google.com, go to webinar, in my case, and I'm going to create new Google Sheets, blank. I'm going to call that DHE22. All right. I am going to do some coding here. I'm going to do some coding here. Basically, I can show you the slides later on. Yeah, basically, what we can do here is to set up Google Sheets to respond or save the data. What we do is simply, in this case, copy. Yeah. This is, of course, something that you, unless you have the device, I can share you the file now, and you can copy and paste. But otherwise, you can simply watch the steps. Copy. Now, go to Tools and Script and paste this. Go to Tools and where is the script? Extension? No, it's now in extension. Yeah, app script. Extension app script. We have that. Never mind. Remove and paste. Alamak. It's not nice. It's not nice. This is not nice. This is something that you do not have to see, basically. But unfortunately, it's not written properly. Or Is it? Okay. It's not possible to enlarge it. It's not possible to enlarge it, unfortunately. So, well, basically what we've done is copy and paste this. Yeah, copy and paste this. And we need to change something. Here, spreadsheet ID. Where do we get the spreadsheet ID? Is basically, here is the ID, starting from slash after D, all the way down until C. Copy that and paste that here. Paste. And the page name is sheet 1. Change that to sheet 1. Let me try to compare that. Why do I get the impression that get range, row, column, set value, okay. Column plus plus. Move to the next line. That closes that. That closes for that try. That closes for that. Okay, fair enough. So, first row, in this case, we put the value number. Yeah, we put the value number. Second row, we put date time. Starting from the third, we traverse through the object and get them printed. If you want to set it out, so we have number, date. We are going to send temperature first and humidity. So that is saving. That is done. Project, we call that DHT22. Rename. And we can try to deploy as a new deployment. Okay. Select web app. Who has access? Anyone can access. DHT22. Anyone can have access. And we can deploy. So basically, what we're doing is to allow people to access this service. Allow sign in, allow the DHT22 to send the data. Basically, just do it once. And we need this deployment ID. We copy that. Maybe I just paste it somewhere. Paste into Notepad so that I still have the value. All right. So this is done on the Google Sheet part. Yeah, this is done. Now let's go to here. If you notice, we have the values and we want to send it out to file. Right? So basically go to network and internet. Notice we have Google Sheet. Here in this case, we need to install the library first. Yeah, we need to install the library first. And therefore, before we install the library, we need to connect to the device. All right. And install the library. All right, that is done. Import struct, open. If we look here, we have boot.py and prequest.py. Yeah. We have prequest already installed, which is fine. Okay. But then again, okay, never mind. But it's here. So the next thing that we want to do, I'm confused. How did my device access that? Never mind. Hold on, where is it? Okay. Now that the library has been installed, basically we simply send data to Google Sheet. And paste it down here or anywhere. It doesn't matter, or perhaps here. Yeah. After we print it, we'll send it to Google Sheet. And what are the cells? What are the contents? Deployment code. This is the one that you have to paste. Right? That's the one. Similar to what I have. Right? And what do you want to put? Content. Basically, I'm going to duplicate this and paste that to content. Or perhaps, no, hold on. If we were to do it like this, there will be a single text, isn't it? No, hold on. No, not possible. Not possible. Because okay, that's better. We have to put into different cell, so we put 2 cells in here. It's just that. Delay 5 seconds. But we have yet to have the connection with the internet. I think what I'll do is, I'm actually quite surprised that it can send. Never mind. I'll try to run the script. Console error DHT. Zoom is outbreak. Okay, it's not working. If it's not working, then we'll try to connect to Wi-Fi. Yeah, I'm going to use my phone. Personal hotspot. All right. All right. Connect to Wi-Fi. Start that. Perhaps I can perform some logic first. If check, hold on, not internet. Check if scan Wi-Fi network, Wi-Fi current IP. Oh no. Nope, nothing. No, never mind. Let the send console. HT 917 measure. It's not working. So I'm going to delete this. Block. Oh. Sorry. And the reason why it's not working is basically right. Now hold on. Silly me. The reason why it's not working is because we have not connected the sensor onto here. So I am going to stop the connection and connect the sensor. I have the sensor. Check the block again. Connect to GPIO 5. All right. Okay, there's never mind. there is basically a slight problem. Problem in the sense that where is I'm showing you what I'm doing. Problem in this. Okay. The problem here is that I have to change the port. You see, the breadboard can only allow one part of it exposed to the connection, while the other part does not have any exposed pin to connect to. So since I am going to need 5 volt, I am going to need 5 volt, I have to connect to any ports from any pins from here, any pins from this side, and I can see that I can use pin 13 or 12 to connect to my sensor. To my sensor. Right, so I'm using one to connect to 5 volt. I'm using another one to connect to ground. That is the ground. I'm also using another one to connect to 5 volt, ground, and let's just say D12 for the data. Now the first pin is VCC, the second pin is the data, and the fourth pin is for the ground. First pin, hold on, where is it? Okay. First pin for the data, last pin for the ground, the second pin for the data, power, data, and ground. Connect them together, and I have that setup. And there you go. That setup. And send the file across. Oh no, hold on. Connection, power from USB. Connect. So file is sent. Run the program on the block. Connect to Wi-Fi. Well, still error. How come I never had this problem? It's not working. All right, if it's not working, we'll try again one more time. Console. Wi-Fi is connected. DHT is not working. Audio. Why is it not working? 12. Block. GPIO 12. Send it. Console. Wi-Fi connection error. Disable. send it console. DHT is not working. For some reason, it just won't give me refresh, reset, enable, pin 12, and run. Guys, unfortunately, it's not working for some reason. But the code has been working all this while. The last 4 days, it's working just fine. There's nothing wrong with DHT. But somehow it just won't work when I try to share this with you.
It's okay. Sometimes it happens.
Not today.
So basically, this is like sharing the data in Google Sheet, is it?
Correct. And I have done this in my other file that hold on, let's see. And let me see. Is it here or the other file? DHT sensor. Yeah, basically these are the kind of data that has been saved that I've done. Yep, 23rd of, this is 24th, yesterday. This was done yesterday.
So basically we can export all the data from the sensors into our Google form, Google Sheet and Excel, and then we can do research on how the temperature changes and stuff like that.
And not only that, you can also send it across to MQTT. Send it over to MQTT. In my case, I have set that to what was it called?
So we can see the trend of the temperature, humidity, and stuff.
Correct. Hold on.
Nice.
I'll just show you what I've done. It's Z135R. It's Z135R. So these are the data that I've tested, sent across to MQTT using the codes. They're using the codes like I have here. Right? This is the code I have. Send it across. Notice easy MQTT start. This is using basically this is standard that IoT are using. The standard that IoT are using to send the data across. So start the MQTT, start the sensor on this particular pin, run it 10 times, send the data to spreadsheet, and this is the deployment code put into different cell. Basically, first it published the data to here, so we can get the value and also save the data into the spreadsheet. So yes, that's the intention of this whole project. Somehow it just doesn't seem to work while trying to show this to you. But these are all recorded and you can try it if you have the device. Yeah. Itu je lah kot. Unless you have any question to ask.
Okay. Any question from the participants? Okay. I guess it's already 1 o'clock. So before we stop, okay, I would like to express my gratitude to Mr. Suhardi and all the participants. Can I ask you guys to switch on your camera so that we can have a photo session?
Hold on, I'll start presenting. Okay.
Okay. All right. Cik Ahmad Kadi. Okay. All right. Okay. In the count of 3. 1, 2, 3. Smile. Okay. Freestyle. All right. Okay. Thank you, everyone. So I see that Mr. Suhardi have shared with us the link to
It's the folder. Yes, the folder that I call my files. If you are interested to have a look at perhaps these files.
I see. Okay. All right. Thank you, everyone. Thank you, Mr. Suhardi. Thank you, everyone. And I hope to see you guys again. So have a nice day, everyone. Thank you so much, everyone. Bye. Assalamualaikum.